Assalamualaikum. I am MTS Choudhury. Today I am going to present pattern matching algorithm, which is a KMP algorithm. This presentation is submitted to Wahidur Rahman Sir, Assistant Professor, Institute of Information Technology, Noakhali Science and Technology University. Let's move on. KMP algorithm, which is Knuth-Morris-Pratt algorithm. It is pattern matching algorithm. KMP algorithm is the first linear time complexity algorithm for the, string matching, and this is developed by analyzing the naive algorithm, where the complexity is order of mn, and then finally it is improved to order of m plus n, which is the complexity of KMP algorithm. The KMP algorithm is named after after wrote the paper on KMP algorithm by the inventor Donald Knuth, Vaughan Pratt, and James Morris in 1977. In basically string matching in basic string matching matching algorithm is naive algorithm, where this is the this is the text and this is the index, and we have to match this pattern, uh, whose length is n and the text length is m. And firstly we have to match the index wise. Here a and b, there is mismatch, and then we check, we increase the text index b, which is one index, then we see the this what b and b, which is meshed, and then increase both text index and pattern index, where is c and c, which is meshed, and again increase the index of text and pattern, where we find b and g, where is the mismatched. Then we again backtrack the text index, which is c, and c, and again we have to start the beginning of the pattern, and where is b, and we see is it matched or mismatched, and where and b or c is mismatched, and then we increase the text index, where we find the b, and b is matched. Again we if is it is matched, and then we have to increase both text and pattern index, where c and c is matched, and g and g, and and l and n is matched. This is how the naive algorithm is worked. If it doesn't exist, the if pattern doesn't exist in this text, we would return an exception or -1. Next, uh, next it KMP comes, KMP is a substring search algorithm, which is developed from the naive approach or naive algorithm. Now we can see the text index 0 and pattern index 0. A and A is matched, and then we increased both text and pattern index. B and B is matched, C and C, but here X is not matched with D. Then finally we see the previous section of pattern. There is any suffix is matched with a prefix, uh, that means here any suffix with the same prefix? No, because here is three individual word. So we have to backward this from the index of a, and then we again check x and a. There is mismatch, and we have to increase the text index to a, and check a and a is matched, and again if matched, again we have to increase text and pattern index, and b and b is matched, and c is matched, and again d and d is matched, a and matched, again b and b. Here x is not matched with c. Then we see the previous part of pattern. Here we can see a suffix with same prefix. So now we see before C we have A and B. Again before X we see A and B. So we do not repeat this section on becoming backtracking from C to A. We can remove this repetition, and so we have again we can start from C, because A and B is already is there. So we can check X and C. There is mismatched. So there is again mismatch, so we have to check before the part of C. There is no same suffix prefix, so again we have to again start this section of pattern of index 0. So we start again A, and this X, this is mismatched, and then we check this next index of text a and a is matched, again b and b is matched, again c and c, d and d, again a and a, b and b, c and c. Here d, dear d is mismatched with y. So we again check the previous part of y, and see that there are same suffix with prefix. Here this is abc and abc. So we can start from D, because there is a part ABC is the repeated part of ABC. So we can start this section, this index D, and we can see D is matched with this D, matched with D. This D is matched with this D. Again if matched, we have to increase the index of both text and pattern, and here A and A is matched, and again B and B, again C and C, and again Y and Y. Then finally we found the string, which is pattern in this text. uh, Again there is a efficiency by making a array from before the matching the pattern and text. We have to make a array from the pattern. Then how can we make this array? Here uh, here if this is I and this is J, then we have to match I and J. Here A is not matched with B, so we can increase the I index from this to this. again A is not matched with this C. Again we can increase the I index, I plus 1. If this there is mismatch, then we can input 0. Here is 0, and again this is 0, again this is 0. Again we can set this I in D, and if we match A and D, there is mismatched. Again if mismatched, we can input 0 in this value section. And finally if we increase the index of I is in here, we can see A is matched with A. If this is matched, then we see the J index 0. Then we insert value index J index plus 1, which is 0 plus 1, 1 is 1. And if this is matched, then we increase both J index and I index. So J is now in B and I is now in B. Then C, B is matched. So we see the Z index. Now Z index is in 1, and finally we can input the value Z index plus 1, which is 1 plus 1 is equal to. Again is matched. J index is increased in C, and B index, I index increase in C. Here C is matched. Then 2 plus 1 is equal 3. Again increase the index of I and J, and now J in the D, but I is in A. There is a little bit tricky, that there is a mismatch. Then we can check the previous index of J. Previous index of J is 2, and then we will go to the two sorry here previous index value. We have to check previous index of value is 0. Then we have to go to the 0 index of J. Then we have to go J is in here 0 index. Now J is in 0 index, and then we have to find if there is match or mismatch, and see that A is matched with A. And then J index is 0. Then we can input the value 0 plus 1 is 1. Here time and space complexity is order of n to make this array. Then finally we came the our main algorithm, KMP substring search. Here is text pattern, and we already create the pattern index with array, uh, where we can make this array by complexity of order of n. Again we can see this how can this we can make this array. This is J and this is I. Then we check if this is matched or mismatched. This is mismatched, so we can input 0. Find initially this is 0 and this is 0. Why because this is mismatched. Then we can increase the index of I, and we can check if we can check A and C is mismatched. Then again we can input 0. Again increase the I, A is matched. Then we can check the J index and put the J index plus 1, which is 1. If this is matched, then we increase both I and j index. Now j is in here and I is in here. This is meshed. Then we can check the j index. Then j index is 1 plus 1 is equal to 2. Again we increase the I index both, uh, as well as j index. Then we can see there is mismatched. C is mismatched with Y. So we can see the previous index value. This is the one previous index and the value is 0. Then we have to go the Z index to 0. That is the initial index. And then we can see again uh, there is a mess or mismatched. Yes, this is mismatched. So uh, this is again and again repeatedly occur. So this is mismatched and there is nothing to mess this here. We can we can put the index of this index. uh, so this is 0 is 0. uh, now now we have to match the pattern if in the text if there the pattern is exist or not. Now see, a is a here, is matched. Again b is b. Here x is not matched with c. If it is not matched, then we cannot backtrack the index of text, but we can backtrack the index of pattern. So here we see the previous index value. This is 0. Previous index is b and this value is 0. Then we have to come the 0 index of pattern. Now again we can see a or x is matched or not. Here is this is mismatched. Then we can we can increase the text index. This is a. Then we can check a is matched. Then increase both text index and pattern index. B and b is matched. Again c and c is matched. Again a and a, b and b is matched. But C here, C is here is Y. This is mismatched. So we can see the previous pattern index of this is 4 and the value is 2. So we have go to the 2 index of pattern. 2 index where there. This is the 2 index. This is the C. Now we can check this is matched or not. Now C is matched. Here again additional information is there is we can see the same suffix and the same prefix with same prefix. So this is ab and there must be ab. So we can't start this the starting index because this is the repetition. So we can start this. This is the most efficient array which is helping us to uh, uh, pattern in this text more efficiently. So here again come to the point. Now we can see the C and C is matched. Again A and A is matched, B and B is matched, and Y and Y is matched. Finally we can find this uh, pattern in the text. This is how the algorithm is worked. Now we can see the text complexity is order of n, and the making of the array is the complexity of order of n. The total complexity is the order of m plus n, but the space complexity is order of n, which is refers or indicate the making only the index, only the array, which is order of n. Let's move on. This is the code section. Now we can see this is the code, and this is the substring. This is the loop and the block code, and for this uh, suffix to make suffix or prefix, same prefix, this is this section. And this code is three part. uh, we can see and make this very easily. And this is the string, and this is the substring to match if there is exist this string or not. You can check this. Now came on the advantages of KMP. KMP is free processing and always predefined, and there is no worst case or accidental input, and this is the efficient for the larger spaces, because this is store the location of the linear by creating linearly, creating uh, creating the array for this linear algorithm. And the algorithm needs to move backward in the input text. This is particularly favorable in the processing a large file. If we can see the disadvantages, if there is matched alphabet is larger, then we have to face more occur, more errors. And secondly, this is not efficient for the smaller organization. Then finally, we can say the KMP algorithm is the most popular and helpful for enterprises all. And again, we can benefit it if we are in the career of data science, or in general or search. And finally, KMP is ideally suited for data science and research, since or because it is the worst case fault resistant algorithm. Thank you everyone. If there is any inquiry or suggestion, you can comment below. Assalamu alaikum.